Hello, everybody. Today we are going to talk about Python lesson 3 and 4. We are going to talk about technical session numbers. We are going to start technical session number 6. It's about today. It's about data structures. So we will talk about types of data structures, just like lists, tuples, sets, dictionaries. And then we start talking about operators, membership, identity, built-in functions, or method. We will cover this in lesson 3, and in lesson 4 we will cover the control statements or control flows like Boolean expressions, for, while, break, continue, and zip, and enumerate. This we will explore them in our discussion today. First of all, we start with lists. Lists, just maybe a list of things like that. Okay, we open Visual Studio. We open Visual Studio and then make this list. This is just a list. We can print this list, like print list of random things. Just Control F5 gives us the list. It is defined by this bracket, and then separate every item with the comma. We can add numbers, integer numbers, we can add float numbers, we can add string, we can add Boolean numbers, Boolean values. So everything can be added, even one object can be added to the list. The list can include any type or data type. Of course, I can call some specific item, like the item number 2. The item number 2 is a string because this is the item number 0, item number 1, item number 2, and this is the item number 3. Control F5. It is a string, as here. This is the out. We can also add another indexing with negative. Negative 1 means the last element. Negative 1 means the last element. We can run it and see the result. It is the last element. -1, it is the last element. -2, it is the one before the last element. The one before the last element. It is a string, and so on. We can also get, for example, in range, for example, starting from 1 to 2, but not including 2, or 3, not including 3. So 1, 2. 1, 2 is 3.4, and 2 is this one, not including 3. Do remember that, not including 3. Control F5. So it is 3.4 and a string. What if we want to get all the numbers after the first one, after the number 1? So I can remove this index and say 1 to all. 1 to all means include 1 and 2 and 3 to the last element. So it will give me the last element. Of course, we can revert to this. We can say to -2, starting from the early beginning of the string of the list. It will give me starting from the beginning to the one before the last element, because it will not include -2, so it will just include 1 and 3.4. These are the how to index the string. We have also the length of the string. So I can print the length of string of list is, and then we say len of list of random things, and just to go to F5. The list, the length of this list is 4, so because it contains 4 items. Contains 4 items. Okay, going to next slide. Slice and dice with lists. As I told you, I can go to 1 to 2, 1 to 3, and 1 to all. What about in and not in? Okay, that's good. Let me see, check to see print 4 in list of random things. Just to check if 4 is in the list. Of course, this will result in false because 4 is not in the list. Because it's false because 4 is not in the list. But if I say not in, it will give true. Not in, it will give true because 4 is not in the list. So I can change this to something that I know it is in the list. Number 1 is in the list. Value 1 is in the list, so it will give us true. Okay, that's what is meant by slice. We have something is called mutability and order. Mutability means the mutability means the list is mutable. Mutable means it can be changed. I mean the content of it can be changed without taking another copy of it. But a string is not mutable or immutable. A string is immutable. Why it is immutable? We cannot change the string unless we take another copy of it. We can, for example, we get substring. We can get substring, but we cannot change the string itself. And order, they have specific orders, and the order is not changed unless you made it yourself. So we can say list is mutable and ordered. Mutable means it can be changed. So I can say list of random things of 0 equal 1. Instead of the number, we can make it string, but I have to print the results to see. I have to print list of number of random things and Control F5. It will give us 1 instead of 1 instead of this one, as you see, because we changed it by using this. We can change it because it is mutable. List is mutable. Okay, so list is mutable. We cannot change the orders. Also, we cannot change this order unless we made it ourselves. It keeps the order of the element, and the order is important, so it is ordered. The list is ordered. So for everything, for every data structure, we can say if it is, we have to ask ourselves if it is mutable or ordered. I have to check this. We have to check this. Also, another useful functions for list is like len, max, minimum, sorted, join, append. Let's check them one by one. Let's check them one by one. Okay, let's do another simple list like li equal 2, 3, 1, 8, 10, 3, 1, 2. This is our list, and we get the maximum print max of li, and we check Control F5. It will give us the max, which is element 10. We can say minimum. Minimum. We can say length or len. We can say sorted of li. And also, okay, let's try this first. This is the maximum is 10, the minimum is 1, the length of the number of the items in the string is 8, and this is the string after sorting it in ascending order. So the result of sorted of Li, it gives another list. The other list is sorted list, as we see in the results here. What about the join? What about the one called join? Join, okay? I can join between these. I can do an example like str1 equal I want to go to the cinema. I want to go to the cinema. Okay, I want to make list of this string. So the best way is to say li equal or ii, for example, or str li str equal str1 dot split. Okay, it will split including by the space. So we have a space here between each word, so it will split this to 1, 2, 3, 4, 5, 6, 7 items. Okay, let's run it and see the result of printing. Let's remove this, we don't need it right now. Okay, list str or list r string split, and then we print the result here to see our result, listr. Control F5. So this is the result, which is I in one item, want in another item, two, and so on. What about if I want this, which is a split, to rejoin them again? I want to rejoin them again. So you can say, you can say, or you can use list str.join, join. List str dot join. I think no, I think I have to make something like that. Dot join of listr. Okay, this will join the list again, but this time it will give instead of a space, it will give underscore. So I will print the result here. List. Can say okay. Original str equal. I will print original str. This is the original str, but if, of course, I can return back the original str if I make space here, so it will get something like that. I want to go to the cinema. It is split. I split it and then join it back with the join expression. For the tuples and sets, we have the tuples is immutable. I mean, the tuple cannot be changed. The tuple cannot be changed. And of course, if you see the suitable example here for the tuples is longitude, latitude. So location is longitude and latitude. Of course, you can use these two types of brackets to define the tuple. But if you use this one, you define a list. So we define a tuple with these two. Of course, I can remove it. If you remove this, it will work too, because now it knows that this is a tuple without the brackets. Okay, so you can do it like that, or without the brackets. They are two working. The same thing is working. Of course, you can index it, or you can even get a range as we do in in the list. Okay, so better if you take an example like A, B, C equal 4, 5, 6. So A is 4 and it is a tuple assignment. It will give us something like print B, and to see the result of B, which is control F5 is must be 5. We print 5. 5 is the value of B. So it gives it takes a tuple and assign the left-hand side tuple to the values in the right-hand side tuple. So 4 will be assigned to A, and 5 will be assigned to B, and 6 will be assigned to C. Okay. Okay. What about the set? What about the set? Let's revert back. Okay. Set is different data structure here, but it is not even data structure, but it is the it is just like lists and the tuples. I can say li set equal set of li. What is the result of this one? It will give the numbers here without repetition. It will give us the numbers without repetition. Let us print li set to see the result. The result is 1, 2, 3, 8, 10. 1, 2, 3, 8, 10 without repetition, because 1 is repeated, 2 is repeated, but it will not repeated in the output. It is just 1, 2, 3, 8. This is a set. This is a set. You can append something to the set. You can just do it like that. Li set dot add 60, and then print li again. Control F5. It will add 60 to the set. We can pop the last thing. So li set dot pop. It will remove the last element, and we can print the result to see the last element removed by using pop. So it removes actually pop, so it removes the first element and leaves the last element. So this is the set, the original set. This is the set after adding 60, and the last one after removing or popping the first element of the set. Okay, and for dictionary and identity operations and identity operators, we can define dictionary. It's very easy to define the dictionary here. We can do it like elements, hydrogen, helium. We can add another thing like oxygen. So I do it oxygen. I don't know the exact spelling of oxygen, but anyway, it is okay. 4. Okay, so we have how many elements here? We have 1, 2, 3, and 4. We have here, this is called the key. This is called the key, and this is called the key, and this is the value. So I want to get the elements of oxygen. The element of oxygen and print it. Control F5. It is 4. It will, because I want the elements of oxygen. So I can call this function without by using the key. I can use the key to call this function, to call this element, not function. I can use elements of oxygen to get the 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 corresponding value. Okay, this is the dictionary. This is the dictionary. I can add another element by using something like elements of course, I add something else like helium. It is there. Methane. I don't know also if it's elements of methane equal 11. Control F5. I have to print our elements again. So I have added methane 11. I have added methane 11 as you see in the result. So this is the way of adding an element. This is the way of adding an element. Of course, you can get the element 2 by using the word get. I mean, you can use get to get the value you need. For example, print elements dot get. You can see carbon. Elements dot get carbon. Control F5. Carbon is not there. He's just returned none. None means the carbon is not there. But because I have added double O, so I have to remove this O and run it again to get 6, which is the elements of the carbon element. Okay. Also, we can add if the returning value is not true or none, so it will display a message like this element is not there. For example, if I do another one, like what about magnesium? Magnesium. I'm sorry for the spelling because I don't know exact spelling. So it is not there. This element is not there. So if the element is there, it will display the value. If it is not there, it will display this non-existing element message. Okay. Okay. For this lesson 4, we will talk about the control flow. We will talk about the conditional statements like if statement. I think this part is very easy for you, for any beginner in the programming. It will be very easy for you to cover. I think this is not a problem at all, but I will just explain them here very quickly. We have if, and the else if is just elif, not else if as any other language included. And for the Boolean expression, you can add to the power of, and you can check the and, you write it and, or you write it or, and not, and or, you write them as this one. Okay. Also, don't do that. Don't do that. If true means that it will execute, it will be executed for always will be executed because the condition is also is always true. If is called or not is called. If is called or not is called, it will result in true always. And also, if weather equal snow or rain, you cannot do that, but you can see if weather equals snow or weather equal rain. This is working, but this is not working. This one is not working because you compare Boolean expression with string, so it will not work. It will just be running, but it will not get the expected value. And also, if you want to see if it is cold, so you can say if it's cold, you say equal true. If it is cold, equal true or not, you just remove equal true. There is no need to include equal true. That's working too. Okay. For the truth values, we have the values that is translated to false is none and false. They are false. 0, 0.0, and 0j, imaginary numbers, decimal of 0, factorial of 0, and 1, they are all translated as false. Empty sequence or collections, all of them are translated as false. As an example of it, you can say errors equal 3. If errors, you display the number of errors. But if no errors means that the errors are 0, so it will be like that. The for loops, you can, for loops are interesting in Python because it is different than other languages. For example, you can say for city in cities. You have cities here, and you can say for cities, for city in cities, for city in cities. So city will be this one, that one, that one in each iteration. And also range. Range is a helpful function that gives a range of numbers. So this will give us 0, 1, 2. It will not include 3. As I told you before, not including 3. The last one. You can build dictionaries like that by using two methods. You can revise them. This is very straightforward. And for while loop is used when you are not expecting or not known in advance the number of loops that you will iterate. You don't know the number of iterations, so you have to use while loop. Break and continue. Break and continue. Continue means that you skip this one and continue, but this is break, get out of the loop. For zip is just combining these two lists together, so the two lists will be resulting in a list of tuples, like that. Of course, you cannot you can unzip them by using zip and star. Zip and star unzip these two lists and return back letters alone and numbers alone back, returning them back as the beginning. Enumerate, if you want to make an index for elements into a list, you can use enumerate. Enumerate give you I, and which I is index for each element. For list comprehension is used in ways to make very quick list, and the list contains an expression and fully expressed or full expression. I mean, for example, if you want to get the squares, you see x to the power 2 for x in range 9. If x mod 2 equals 0 means that I will make powers of the even numbers only. We can see the result of this actually in a quick way. print squares. Okay, so this is the squares of 2, which is 4, squares of 4, which is 16, squares of 6, which is 36. No square of 5. No square of 5 because this is condition. You just say, give me the square of of even numbers only. So the square of 8 is 64. Okay, and that's all for today. Thank you, and I'm looking forward to see you again in next week, inshallah. Goodbye.